This is the first of 3 videos where I'm talking about angles. In this video, I want to talk about parallel lines and their corresponding angles, vertical angles, supplementary angles. I'll touch on complementary angles. The other 2 videos, we're going to talk about polygons in particular, because in plane geometry, we really only have 2 kinds of questions. Questions about shapes and questions about lines in space where we don't care about the coordinates, which otherwise would be in coordinate geometry. So let's get started. Parallel lines are so important on the ACT. They show up all over the place, and if you see an angle question, there's a really reasonable chance that it's going to be the key to solving it. In fact, a lot of times angle questions are sort of almost disguised as triangle questions, or they're like angle questions with a triangle kicker, or it could kind of be the other way around. It's like, oh, it's really a triangle question, but there's like an angle bit to it, angle component to it. And parallel lines are often at the heart of this. Now, remember that parallel lines, I know mine aren't the best, are 2 lines that have the same slope. They never get any closer together, and they never get any farther away. Same line, different address, different y-intercept, right? Same slope, different y-intercept. They have to have different y-intercepts, because if they don't have different y-intercepts, they will be the same line, identical. Does that matter too much for plane? No. Here's what matters. Corresponding angles. Now, I don't care about definitions. If you've watched a bunch of my videos or had the misfortune of meeting me on Skype, then you probably already know that. Definitions and labels aren't that important to me. Concepts and how things work are. So really, what I'm going to try to get across here is that, see, look, this lines never change directions. They go straight forever and ever and ever and ever, right? When it crosses one parallel line, it's going to have the same relationship here as when it crosses that other line that has the same slope there. These angles correspond to each other. They're identical. They're identical in measure. And of course, these angles, the big angles, are identical in measure. It doesn't have to be any more specific than that. If you know the lines are parallel and you can track a line through both, these angles are just going to match up. And, you know, we'll get into all this, but of course these angles are equal there as well. So, vertical angles, which is what I said we get into. Let's go ahead and get into it. Vertical angles. So when I have this X here, you see this X, how they cross? Boom, boom. That little scissor makes identical angles, right? Because those lines are straight. The angle coming in has got to be the angle going out. So this is the same, and this is the same. This is the same, and this is the same. And finally, supplementary angles. Now, I'm going to quickly freehand a circle, so this would be a good opportunity for some unintentional humor. Let's see how that looks. Kind of looks like a Mr. Potato Head. But a straight line, if this is a circle, a straight line would be like a diameter. And that's 180-degree angles. Or it's a 180-degree angle. So the straight line's 180 degrees. Whatever angles that add up to 180 degrees will add up to a straight line are considered supplementary. So this and this angle are supplementary. All 4 of these will add up to 360. That's kind of the important stuff. So know your parallel lines. Be able to recognize corresponding angles. Look for vertical angles. And look for supplementary angles. That's 90+% of what you're going to need when it comes time to solve these angle questions or questions involving shape and angles. And there's a lot of them on here. So know that stuff and you'll be in good shape. Now, in a second, we're going to pop up a full screen ACT problem and go ahead and work through it. Very representative of the standard angle problem you'll see on test. Okay, we're looking at a pretty standard setup for an angle question here. First thing I want to do is I always want to transfer as much information as I can from the question to the diagram. Even if I'm drawing a diagram, that's the case. I want to make this diagram as complete as possible because I want to really essentially kind of be able to throw away the question after this. It tells me AB and CD are parallel. I always mark that with train tracks. And it asks me for the measure of this angle. They've already been kind enough to mark it for us. So I got a couple parallel lines here. Looks like supplementary angle going on. Looks like I'm going to use a vertical angle to find this thing finally. And I'm kind of ready to get started. You see, I've got these triangles here. These triangles. I got 2 triangles. I got a little baby triangle and I got a big triangle. Now think if I find two angles in this big triangle or the baby triangle, I can find this top angle, which through vertical angles will be the same as the angle in question. So starting with the supplementary angle, let's say, well, okay, so they add up to a straight line, so that's 180 degrees. Minus 115, that's 65. And again, mark things up as you go. So 50 plus 65, well, I need that third angle of that triangle. So again, it's going to be 180 minus 50 minus 65. And it's actually going to turn out the same. 50 plus 65 is 115. So it'll be 65 again. And this top angle is 65, which means the angle in question through the vertical angles is also 65, and our answer is 65. So you could have also looked at this problem, get a little bit off that screen, by saying, well, look, these are parallel lines, so this little baby triangle, this little tiny triangle, this will be 50, and this will be 65, and that'll be 65, and then that'll be 65. Not really a time saver here. A lot of times you'll actually need those parallel lines. This isn't one of them. Now, when I started the problem, I had an end game already in mind. I already knew how I was going to finish the problem. And obviously, I wrote the problem, so I should, right? But I want to really reinforce to you guys, you don't need to do that. You don't have to know how you're going to finish a problem before you start it. You just have to know how to start. So even if it's as simple as saying, well, look, I don't know what I'm going to do with anything else. I don't even see this triangle there, but I know I can find this angle. Start there. A lot of times the way will open up. It's as much about adding information to your diagram as it is about building your confidence in the fact that you can interface with it, you can interact with it, you can do stuff. So definitely work on these. It's an absolutely crucial skill. And make sure you check out the next two videos, interior angles and exterior angles of polygons. Now the interior angle stuff, you got to know it. There's just no way around it. The exterior stuff, it's not as big a topic, but it has shown up a bit more often lately. So you want to take a look at that as well.